In this video, we demonstrate DetectorDetective, an interactive tool that helps visually understand the journey of an image through a deep learning object detector model. This is accomplished by allowing the user to get a look within the internal modules of the object detector to better understand its behavior. This tool allows side-by-side comparison of the key modular components in the object detector for benign and adversarial images. By observing the progressive changes in the intermediate feature activations in the network, the user can gain insight on the impact of adversarial attacks. The interface of DetectorDetective allows iterative exploration by choosing from a set of images, viewing the intermediate behavior and the model outputs for benign and adversarial versions of the input. The image viewer allows selection from a set of images to use as inputs to the object detector. For each image, the original benign version is displayed above and an adversarial or attacked image is displayed beneath. The adversarial example contains near imperceptible perturbations crafted to fool the model into either misclassifying the image label, hallucinating objects that do not exist, or predicting an incorrect bounding box for an object. The module inspector allows exploration of the three major components that comprise the object detector and their intermediate outputs: the backbone feature pyramidal network (FPN), the region proposal network (RPN), and the region of interest boxhead (ROI). Toggling between each of these modules within the interface helps users understand the role played by different modules. The backbone module inspection allows us to view the outputs of the FPN and the 5 feature maps extracted at varying depths, each with progressively higher receptive fields. Selecting the RPN module inspection shows each of the feature maps from P2 to P6 fed into the RPN, resulting in 5 different objectness maps and anchor deltas maps. The objectness maps show whether or not an object is located at a particular place, while the anchor deltas give us an idea about the presence of an object and its orientation. Selecting the ROI module inspection demonstrates how the boxes identified in the region proposal network are passed to the prediction stage to obtain the final image labels, boxes, and scores. In the explanation viewer, the user selects between viewing the overall detection, including the labels, bounding boxes, and scores. The GradCam selection is a saliency mapping technique that shows the general region that the model is paying attention to. The gradient selection shows the pixel level influence of the gradient in the image. Exploring, investigating, and understanding model perception. Let us say that we want to understand how the network interprets the image of a kite, both with an original benign input as well as with an attacked input using an adversarial image. In the overall detection, we notice that the model correctly classifies the single object, a kite, with 100% confidence, and plots a bounding box that correctly captures the entire object. On the other hand, the attacked image causes the model to hallucinate and see many objects that do not exist. We also see that the model misclassifies the kite as a car. Now we want to understand how the object detector sees these images internally. From the backbone module, we can gain an intuition that the features of the kite are faithfully extracted in the benign image, but we see that the attacked image immediately shows feature extraction from areas of the image that do not contain actual objects. We can build on this intuition by selecting the RPN module inspection and initially leaving the map to its default objectness map. As we see the progression of outputs from P2 through P6, the benign image causes the model to focus on a single object, while the adversarial image shows that the object detector cannot seem to settle on any particular area, and instead sees many objects. We confirm this understanding by using the GradCam saliency map from the overall output, showing a focus in one region in the original image, but several regions in the adversarial image. This example demonstrates how the model correctly interprets a benign image and also gives us insights to the locations within the object detector where the model fails.